Okay, so this video I'm going to show in a very awesome and exciting way that the medians of a triangle are concurrent. And the pictures I'm using are from an old geometry program, so it used to be really cool. I could hit all the steps and it would fill it all in, and I'd feel really great about myself. But that's come and gone. So um, I've constructed triangle ABC. It's just a regular old triangle, nothing special. I constructed the midpoints D, E, and F. Then I constructed BE and AD, those two medians. They intersect at point G. And what I need to show is that if I construct CF, that it will go through G. That's kind of how I'm going to show um, this proof, is that CF is going to go through G, and then it must mean that all three lines are concurrent. Okay, so our second step is that I'm going to so this everything's the same as the first picture except for X and Y. I created the midpoint between C and D and the midpoint between D and B. So that's X and Y. And then I also construct a line EX and a line FY. Okay. And so you're looking at that and you're going, those kind of look parallel to AD. Maybe that's what I'm using. I don't know. I hope so. So now notice that triangle A, B, D. So this triangle right here. Let me see if I can get a little pin here. So this triangle right here, that triangle ABD is similar to triangle FYB. So FYB, there are these two, this bigger triangle and this bigger triangle. And why is that? Well, we've got the ratios, right? So this over this is the same as this over this, and they're both half. So we can use those ratios to say that these two are similar triangles. Okay, we can also do the same thing for ACD and ECX, these two triangles. So we're showing they're all similar. Okay, let's just turn that off. Okay, so let's go to step 4. In step 4, where are we at? Okay. Notice my picture's in the way. Rude. Okay, so we have all these similar triangles, so we know that FY is parallel to AD and EX is parallel to AD. Okay, and that comes from a side splitter theorem. I think I have it. It's the converse of the side splitter theorem. I think it's down here. No, all I have is the similarity theorems. There they are. That was awesome. Okay, where was I? Okay, but I gave you the math is fun reference here to say why this line, and this line are all parallel. Okay. Okay, so now we can see what we've got. CX is congruent, XD is congruent, DY is congruent, and YB is congruent because we took the midpoints of all of these. So we basically divided CB into fourths. Okay, so all these distances are all the same. Okay. So now let's look at BE. So now BE is divided into 3 segments, and those segments are congruent, e.g., GJ and JB, because parallel lines that are equidistant from each other divide the line segments into equal portions. Okay, so because these are all parallel, they're going to cut this line into congruent pieces. Okay, so if we look at BG, this segment here is 2 times as long as GE, or the point G is 2/3 along the way of BE. Okay, so this point G, this intersecting point that we're aiming for, is 2/3 of the way down this particular segment. So then so we showed that this is 2/3 of the way down. Our next step that we would take after step 6 is step 7. I know you're like, you're horrible at your videos. Would be to do these 2 segments and show that, and let me move this down. We'd do these 2 segments and we would show that CF, that this point G is 2/3 of the way down, BE, this same point, and so all the medians have to intersect. Now, some of you are saying, I don't get that. I would challenge you to go online and find this proof, because I'm just rumbling and bumbling through it. But you could check it. You could check it online. I'll also put this document into ReggieNet so that you can see it. One of the questions you should be asking yourself is, what does this proof do for me? How does this proof help me understand the geometry better? So that's just a proof, and just be glad you didn't have to get it in person, because I'm even more boring in person. Okay, thank you.